Hello, just thought I'd make a video. I already talked about. I had a plan to do a video on astronomy because I took a class on astronomy in college, and here's what I learned. It's pretty crazy. Uh, so basically, now they've been building probes to visit other planets in the solar system. We cannot visit planets in other solar system, but they do have powerful telescopes that they could send in orbit around the Earth because orbit telescope they can see clearer what's out there, meaning that the Earth, once you get out of the atmosphere, well, we can see stars from the stars are always there, but we can't see them in the daytime. But we can see them in the nighttime because they are bright. They're emanating light. So this is they all around the world. We're just surrounded by the universe. So we can look through telescopes to see planets or see stars, and even we also know that there are whole galaxies and billions, as many as a grain of sand that exist uh, outside of our own. The closest galaxy that we know of is Andromeda, and this is located in because the way that we there's like a roadmap to the sky, and these are constellations. So there's this Orion constellation, and near the Orion belt there is Andromeda, the Andromeda galaxy. There's also a nebula there, but all the stars that we see in the sky that are not galaxies are within our locality of the galaxy, of the Milky Way galaxy, because this is our galaxy. But when we see the Milky Way galaxy, this is just because it's we're looking at our own center of our own galaxy, but it's clouded by dust. So this is what the effect is that we are seeing. But this is outside of our solar system. But the course that I did in college was focused on within our solar systems, the planets, because we have sent probes and we have sent machines to do geology on comets, on asteroids. Now we know that there are tons of floating debris in close to our planet in the throughout the solar system. There is tons of just asteroids and comets that are floating around, and that you they can actually land on them and do some digging, take samples, and come back to Earth. And they discovered that water is a common common element in the solar system, not only in the solar system but in the universe. So the Earth is not the only planet that has water. Uh, Also, other planets, we've discovered that the giant planets like Jupiter, and Saturn and Uranus has tons of satellites, natural satellites like the moon. So they would like the moon. When you think about the moon, you think that, oh, it's a moon. But the thing is, there are so many moons and that are orbiting the giant planets, and some of them have properties that are very similar to Earth, meaning that they have atmospheres and that they have water, uh, and they have seasons. So this blurs the line between what is a planet and what is a moon, what is a natural satellite versus a planet. So they just changed that because now they said, oh, Pluto is not a planet anymore because it's too small, and it's anyway. So now they call it worlds, because a lot of the moons around the giant planets are as big as, or very close to the size of Earth. So but however, they have not discovered life on other planets in our solar system. But they did discover a lot of planets on other around other stars. They're saying that most stars have systems of planets. They've discovered more than 4,000 planets. The way that they do this to discover the planet is that they have a corona something that they have in their telescope that they can block the sunlight. They can measure the sunlight, and when the planet comes between our sight of seeing, and also you can see that it casts a shadow almost like an eclipse. So there's a variety of brightness when the planet comes in front of the star that we're looking at. So this is one of the ways that they discover the planets. But these planets, of course, they're too far. We can never know what their properties are. We can never study them. We can never send a probe there. The the distance between us and them are hard to imagine. So, but we could discuss, we could study our planets that are in our solar system, because, well, they're very far, but we have built technology that can go in outer space and travel to these and take pictures and study and land, like we've done that with Mars, the Mars rover. We've sent a lot of probes there. They landed there. They took samples. They studied. There you can actually see the weather there. They have a thermometer, so you can actually see the weather there. If you look at it on the internet, there's a website. You can see if it's windy. You can see how much degrees it is on Mars. Uh, and the thing is that we also have seasons. We have seasons in this is pretty long topic, but we have seasons with on the Earth because of the axis of the Earth. So you have the sun, and you have the Earth that is rotating around the sun. But the Earth is it has an axis like this. So when the Earth is on, say the sun is on that side, it's the southern hemisphere that gets a lot of light, because the Earth rotates on itself, and then once it goes around it and it goes like this, then it's the northern hemisphere that gets more of the sunlight. So it's the quantity of sunlight that we get that makes the seasons, and this is happening with every planet. Every planet has an axis, and every planet is experiencing seasons, so they have a variation of temperature. Some like Mars has ice on its cap, on the polar cap, in the winter, but in the summer it actually melts a bit. It's not water ice; it's a hydrogen, I think, because the temperatures are much lower. So there you have it, and then there's the atmosphere, because we on the Earth have an atmosphere that protects us from radiation from the sun. It is consisted of ozone and oxygen and carbon dioxide, different things, and this is creating if it's a greenhouse effect that captures the sun rays and the heat in and creates a warmer temperature. But this is not, this is unique to the Earth because the other, like Mars for example, doesn't have an atmosphere like this. It does have an atmosphere, but it's the different atmosphere, and it does not protect from the lethal radiation. We as humans, we could not survive on Mars because first of all we can't breathe the air, and then there is lethal radiation that we are not protected from, that comes from the sun, because there's not the elements of the atmosphere that we are used to here. So, as for life on other planets, we have not discovered any life, not even microbes, that exist on other planets. But we have seen that there's an ice moon around the big gas giants, and we are thinking that it is possible that under the ice there is oceans, because usually a planet has a warm core, fusion, a core that is fusion by gravity, so it has volcanoes. And if this particular ice world has volcanoes under the ice, then this means that could have water there and heat, but the heat is coming from the volcanoes, not necessarily from the sun. So, but we have discovered on Earth that there are, in the depths of the sea where no light can reach because it's so deep, it's near the volcanoes, and the water is at a temperature that is 400 degrees. It's way past boiling, the boiling point. There is species of shrimp that can that live there. They don't see because there's no light. They're blind, but they can live there. They live there and they thrive there at the temperatures that usually species do not cannot exist. So there you go. So life can exist in pretty extreme situations, which makes it more probable that perhaps life could exist under ice on other planets. But it would be hard to detect. But it's a possibility.